this next speaker, we're super excited to invite. When we looked at the CFP process, this is definitely one of the talks that stood out. Imad Elyafi, right? Did I say that right?
Yeah, that's right.
You can fix it after. Yeah. What can I say about you? We sent all the speakers like this form, like what is something interesting? And Imad was really interested about Colombia, that we have a wide variety of climates. So as probably all of us know, you can go to the beach in Cartagena and then go to like a glacier, El Nevado, one of them. So yeah, you know, now if you have anything cool to tell our speakers, you can definitely contribute to Colombia fun facts. So yeah, without further ado, let's give a big round of applause to Imad.
Thank you for the introduction. Buenas tardes. Hello, everyone. I'm so excited to be here. And all right, let's get started. And today we're going to talk about how we migrated Pinterest to React. And we'll take a look into challenges we faced and techniques we used while migrating Pinterest profiles to React. A little bit about myself. My name is Imad Elyafi, and I'm a software engineer on web core experience team at Pinterest. I've been at Pinterest for almost 3 years, and before Pinterest, I was at Facebook. That's where I started using React. If you have any questions, please make a note, and I'll be happy to answer them in the end. So first of all, this presentation is not about how to use React or how to build components in React. This presentation is about how to migrate an existing service to a new framework to React. And you can use this as a recipe in your project to migrate from your framework and your stack to React. And one of probably the most common question is, why React and why not any other framework? So the second part of the talk is about how we had to prepare the infrastructure in order to build any component in React. Before we can actually start building something, we had to change our infrastructure. The third part is about measuring the impact, and after you make a lot of changes, you want to make sure that the new changes and the new UI actually performs better than the old one. And in the end, I will share with you the results and outcomes, and as well as how our developer experience has changed since adoption of React. So why React and why we had to move from the old framework at all? And the old framework named Denzel was introduced in 2013. It was built at Pinterest, and it served us well until a certain period of time, but nowadays it's completely outdated. And some of you may ask the question, why React and not Angular, Ember, or Knockout, or Meteor, or any other framework? And on this slide, you can see the list of the requirements that we had for the new framework. And first of all, we wanted to have a large developer community and to be a part of this developer community. And React has a huge developer community that we can take advantage of. Another reason is design patterns. And React has design patterns that makes the migration much easier from the existing framework. The third reason is isomorphic rendering, and React has a solution for isomorphism. And I'll be talking more about it, why this is so important for us. The fourth reason is performance, and React is well known for its performance benefits. For example, you probably heard about virtual DOM and reconciliation algorithm. And the last is developer experience, and our developer experience has changed completely since adoption of React. On this slide, you can see our old stack. It's a Python Django web server, Jinja templates on the server, and Nunjucks on the client. And you may have something similar in your project. But being on board with all of these and having module bundler, GraphQL, and many other things, it's a huge advantage for us. So just to give you an example of scale that we operate at, we have 250 monthly active users. It's more than the population of the largest country in the world, Russia. We also serve more than 150,000 of requests per second. And now let's talk about migration to React. And at Pinterest, we frequently ship new features and we run hundreds of experiments simultaneously. And because of that, we can't just stop the development process, do code freeze, and rebuild a new web app completely from scratch in React. So while you're building a new web app, it's not that complicated. But when you have a huge app with millions of users, migrating such service, it's pretty much like changing engines of an airplane while you're mid-flight. How many of you have tried to rewrite a web app from scratch in React or any other framework? I can see a lot of hands. I did it in the past. It was a nightmare. I ended up in a situation when I had 2 web apps simultaneously. The old one, which is in production, and our product engineers are still porting and making new features and making changes. And the new one, which is still under development process, which you have to support and port all these features. So it's like a constant race condition. So how can we avoid this? And the only way to avoid this is to rewrite your web app piece by piece while the rest of it is still run by the old framework. Thus, you won't have to stop development process, and you won't have to implement features in 2 places while your engineers will be able to continue make changes to your product. So we're coming to this idea of so-called hybrid app. It's an app where you have 2 frameworks and they coexist together for a period of migration. And now we're coming to a question, how can we make a hybrid app? And the first thought, it's not that complicated, but let's take a look at the list of all possible challenges. So first of all, React is a JavaScript framework. And how many of you have JavaScript on the server side? I can see maybe like 20% of hands. Over time, it's growing, but it's still not a lot. And on the server side, you can have many different languages. For example, we had Python. Some of you may have PHP or C# or any other of them. And obviously, having JavaScript in all of these languages is not a common thing. And some of you may ask the question, why do we have server-side rendering, and why isomorphic rendering is so important to us? And there is 2 main reasons. First of all, if you have the same language on the client and on the server, your engineers will not have to write your templates twice, right? So you save their hours and work. And the second reason is SEO, and we run a bunch of experiments, and it's still much better to send your initial markup as an HTML. So that's why we need the isomorphic rendering. So the second challenge is rendering your React components inside of the old framework. And it can be challenging, for example, if your templates, they are stored in separate files, or you have a custom templating language, and such example is NodeJS in JavaScript and Jinja in Python. And the third challenge is dealing with old data layer, and more likely you have a resource library that does all the communication with the API, and probably at least for the first period of migration, you want to keep this library so you won't have to migrate everything at once. And in the end, we have to make sure that everything works well, right? Because we don't want to ship changes that are less performant, you drop engagement metrics, and so on and so forth. So now let me give you a very high-level overview of our web app. We have a single-page app on the client. We have Python Django web server and backend API. And whenever a user types pinterest.com in their browser, it sends a request to our Python Django web server, which does all the rendering using Jinja templates and sends back the HTML. So once the HTML is parsed by the browser, it will spawn additional requests. It will initialize the app, download all these assets from the CDN. And after that, all subsequent requests will be happening only to retrieve additional data. So we don't do any more server-side rendering once we render the initial page. Now let me give you a little bit of a context and high-level overview about Jinja templates in Python and NodeJS in JavaScript. And these templates are very similar, almost identical, and because of that we had so-called isomorphic rendering. The only caveat is that we had 2 sets of utils and libraries, one in Python and another one in JavaScript. And it's not the best approach because once you make a change in one place, you have to test it in 2 places, so it's not the best thing to do. And is anyone familiar with NodeJS or Jinja at all? Very few people. It's not that complicated. You can see a code snippet. It's very common to many templating languages. So here we're setting up a few variables. The next line will actually render something. If greeting and name is empty, it will render hello guest, welcome to Pinterest. And on this slide, you can see a module call. Module call is a function call which will find a module named home feed for us and will pass the data and options into it. So people who use React, does it look familiar for you at all? Yes, no? Yeah? So it seems like the whole architecture fits very well into each other, right? So here we do a pretty similar thing. We read properties. We render a home feed module, which is actually a function call. It will be converted from JSX to a function call. And we pass all the properties. So it seems like it fits very well into each other, but how can we render JavaScript in Python? And in order to do so, as the very first step, we introduced a NodeJS sidecar, which is used only for rendering non-JAX templates on the server. Thus, our engineers will not have to stop their developing process and convert everything at once. They can convert our service incrementally and keep making changes to the rest of the app. And as a bonus, there is no more utils, duplicating utils and libraries. So we have only one set of them in JavaScript. And now let's dive deeper into non-JAX rendering, and let me give you a very high-level overview how Jinja rendering in Python used to work before. You can see the old architecture, Python Django web server, Jinja rendering engine, and once a user types in pinterest.com, browser will send a request to our web server. It will request additional data from the API so we can start rendering our template. And it will render our templates serially as far as it can go until additional data is needed. Worth to note that this process is CPU blocking, so nothing else can be done in this thread. Now, when we need additional data, our Python Django web server will send another request to the API, and it will continue rendering process serially as far as it can go. And this process will repeat until the whole template tree is rendered, and in the end, we'll combine the HTML and send it back to the browser. Now let's take a look what happened after we introduced a Node.js sidecar. So you can see now we have NGX proxy layer for load balancing and node workers for non-JAX rendering. And everything starts in the same way when user types in pinterest.com and we send a request to the server. Then we retrieve the initial data from the API, and here where it becomes different. So now, instead of Jinja Renderer, we send a request to Node.js workers, and it will render our template tree as far as it can go until additional data is needed from the API. And at this point, we'll send back partially rendered tree to the Python Django web server, which will request additional data from the API. And now we want to continue rendering process and continue rendering our template tree. So in this case, we'll send multiple requests serially, one per each single subtree, in order to continue rendering of our subtrees. And now you can see this process is no more CPU blocking. So we can parallelize our rendering process, and we continue rendering as far as we can go until additional data is needed. Now the process will repeat itself. It will send back the partially rendered templates. We'll retrieve additional data, and we'll send another request to continue rendering of the subtrees with the newly retrieved data. So now, after we rendered the whole tree, we'll send back the combined HTML to the browser. And as you can see, the process is kind of similar, but for templates rendering, we're using a Node.js sidecar, which is solely used only for non-JAX rendering, which is JavaScript templates. And this parallelization and sending multiple requests per each subtree was one of the biggest reasons for performance optimization. So this process is now not CPU blocking anymore. So at this point, we can render nunchucks on the client and on the server. And now we can move to our second challenge, is rendering React components inside of the old framework. A little bit about our old framework, Denzel. It's a component-based JavaScript object-oriented framework. It's very common to many of them that were introduced 5 to 7 years ago. You probably remember some of them. And on this slide, you can see a couple code snippets. The first one is a module call, which we saw in the beginning, which is a function call which will render the old Denzel module. And the second part is a component call. It's another function call, but which will fall back to React rendering. So in order to empower our engineers to migrate our service incrementally, we tweaked Nunchuck's rendering engine and introduced a new keyword component which represents the bridge between Denzel and React and falls back to React rendering. So once Nunchucks will meet component keyword, it will render Denzel-React Bridge instead. You can see on this slide a very simplified version of this component, Denzel-React Bridge, and it's a Nunchucks module. And now let's take a quick look how it works. So once component keyword is seen by Nunchucks, it will render Denzel-React Bridge instead. And the bridge, on its turn, once it's added to the DOM, it will read its options and figure out the React component name and the rest of the data, all the properties. As a next step, it will render a React component with the options passed in to its own DOM element. And it's pretty simple but pretty powerful technique that can be used in any migration from pretty much any framework to React, and maybe not only React. And some of you may ask a really good question, how React will actually reuse the server-side rendered HTML on the client side. And this is one of the cool features of React. It will basically, once it's rendered HTML on the server, it will generate a checksum. And later on the client, it will compare the checksum which is rendered by server side with the checksum that is rendered by virtual DOM. Not real DOM, but virtual DOM. And if the checksum is the same, it means that the HTML is correct and we can reuse it. So this will prevent a lot of unnecessary flickering or UI issues that you might see because browser will unnecessarily render things on the client. And now we can move to the third challenge and dealing with the data sources. And for that reason, we used hardware components, or HOCs. And HOC is a powerful concept, which is basically a function that takes a component and returns another component. And I know this definition may sound a little bit confusing, but let's take a look at the example how we use HOCs with our resource layer. So on this slide, you can see a with resource HOC on the left side and the example of usage on the right side. It's a pretty simplified version, but now let's take a look how it works step by step. So once a component is added to the DOM tree, it will create a resource layer, basically the old data API framework, which is use resource factory create. And once we got a resource, it will send a request to the API, which is basically a layer on top of AJAX request. Once the data comes back, it will change its own state. And once the state is changed, it will render the inner component with the newly created data. So this is pretty simple, but it helps you to keep in sync with the data that is changed on the server and to feed the newly data to your client-side app. So at this point, we can render React on the client and on the server, and now we can measure the impact and check how our new app works compared to the old one. And this is the most exciting part for me. With more than 250 million of monthly active users, we roll out things very carefully. We want to make sure that we don't break anything. even though sometimes it happens, you know. And how many of you have used A/B testing frameworks before? I see a lot of hands. That's good. So if you have something like that in your project, this is super handy in migrations like that. So in A/B testing framework, you can fork your logic based on experiment check and do one thing or another. In this code snippet, if we check if a user is a new React experiment, then we render a new React component. Otherwise, we fall back to the old Denzel pin module. And now let's look more deeply at the experiment setup. As you can see, on the right side, we have a module tree, and in some node, we fork our logic based on experiment check. And the whole left subtree is in React, and the whole right subtree is in old framework Denzel. So once a node has been converted to React, there is no Denzel call on it. It makes it much easier to migration if you do it one way. You don't want to have Denzel calls from React and React calls from Denzel and vice versa. It will be a total mess. So this is a very good way to move forward quickly and make your migration much cleaner and well thought. And because of that, we call it bottom-up approach, which means you start from the very leaves, from the very bottom components, and you move to the top. It's worth to mention that you want to run your experiments maybe at maximum per single page level only. You don't want to run experiment like old web app and new web app, because you have so many different factors affecting your metrics, so you will never figure out what's going on. And you also want to run all your experiments exclusively, otherwise they will affect your metrics and affect each other. So later on, we can log in our experiment dashboard, and we can see different metrics, and we can compare the old version and the new version based on different metrics. For example, performance metrics like time to first byte, or engagement metrics, how many pins user do, and so on and so forth. You can see a screenshot of our experiment dashboard. It's pretty simple. Blue means there is metrics gains. Red means there is some metrics decrease. Gray means there is not enough data to make it statistically significant. And running experiments in migrations like these is super critical, because even if you have a really good test coverage, bunch of integration tests, automated tests, or anything like that, you won't be able to catch all the edge cases because, for example, what if there is a bug in countries with slow internet connections or in different language, and many other things that are really hard to catch with automated tests. So Pinterest Profiles was the very first user-heavy page that we successfully converted to React, and we've seen consistently performance and engagement improvements. For example, such metrics as DOM interactive and response end were up to 20%, and engagement metrics were up 10% and more. And this happened only because we changed the underlying infrastructure. So we didn't do any changes to the UI at all. So it was the same, no changes to designs or anything. And while we were converting profiles to React, our product engineers were able to continue making changes to the rest of the app. And finally, it leads to a completely new developer experience. So now no more duplicating utils and libraries in Nunjucks and Jinja at all. There is no need to learn Nunjucks to our new engineers at all. And you can go online and find all the documentation and well-crafted examples or anything else. So there is no need in wiki pages anymore. Now we have single language on the client and on the server. And now we're a part of this large React community and ecosystem. It's been a long journey, but it's worth it. And we're so excited to be there now. Thank you. Any questions?